Hi everyone, welcome to our auto insurance fraud detection model presentation for the UT GIS Datathon. So as an introduction, the libraries we used were pandas, numpy, matplotlib.pyplot, and just for some actuarial applications, a property and casualty company can use our model to detect fraudulent auto insurance claims. Some parameters that we excluded were these right here, and they were excluded from the model for being too unique. So for example, the policy bind date, there were 768 distinct data points out of 800, so it really doesn't contribute anything useful to our model. And for part 2, we excluded these, such as auto model and injury claim, property claim, and vehicle claim, just because they were highly correlated with something else, and including both data points when they're highly correlated is a little bit redundant.
So for the categorical column in the training set that we did include, we made Excel graphs to show the empirical probabilities. In the graph, N means there's no fraud reported, and yet Y means there is fraud reported. I can go to the next slide. In our model, we converted those probabilities into numerical data. We can't really tell from these graphs just which ones are the most obvious predictors, but the graphs are still interesting to look at for now.
So the model that we ended up using is a logistic regression that was L2 regularized, and we trained that on synthetic data from SMO upsampling. So the fact that this is a binary classification problem, logistic regression handles that pretty well. And the fact that those classes are unbalanced means that SMO can handle that pretty well. And so, some advantages of that are logistic regression is inherently simple, and those betas that we get from it make for good model explainability. And then some of the disadvantages are that we really can't capture complex decision boundaries when using something like a random forest, for example. So our F1 scores for this was 0.90 and 0.76, and that's pretty good. And as I said before, thanks to using logistic regression, we also found some big predictors for fraud.
So from the graphs alone, we can't really tell which ones are useful, but from logistic regressions, we found that collision type, incident severity, and hobbies are the biggest predictors to insurance fraud.
And some possible causes of error or defects is if an insurance company wants to use our model to detect their own fraud using their own data, the error can occur from data collection, data storage, or scaling.